Two machines produce spatulas. The smaller machine costs $750 to set up and 25 cents per spatula produced. The larger machine costs $1,200 to set up, but only 20 cents per spatula. How many spatulas must the company produce to make it worthwhile to use the larger machine? Now, in this problem, if you look at it, it looks like the smaller machine might be a better deal because it's only $750 instead of $1,200. So the larger machine looks to be a little bit more expensive. But if we think about things in the long term, the smaller machine costs 25 cents per spatula produced, but the larger one is only 20 cents per spatula. So if we're making a lot of spatulas, the second machine, the larger machine, it's less money per spatula after we've dealt with the setup costs. So if we're using this machine for years and years and we're making thousands and thousands of spatulas, probably eventually, if we make enough spatulas, we end up having a better deal with the larger machine. And we want to figure out what the number of spatulas is where that changes from the bigger machine being a bad deal because the setup costs are too high to the bigger machine being a good deal because it's less per spatula. So they ask us, how many spatulas must the company produce to make it worthwhile to use the larger machine? And we're going to let that be X. Let the number of spatulas produced be X. Now, we need to write an equation that models the situation. And what we're going to do is we're going to write expressions that represent the smaller machine and also the larger machine. And we want to figure out when the cost of operating those machines is equal, because that's the tipping point. That's when it might make sense to start using the larger machine. So let's start with the smaller machine. We're going to make X spatulas, and the smaller machine costs $750 just to set it up. So we're going to start with $750. Those are the startup costs. And then it's also 25 cents per spatula. So we're going to add to that 0.25, 25 cents, times the number of spatulas, which is X. That's how much it costs to make X spatulas with the smaller machine. With the larger machine, the startup costs are higher. It's $1,200 to set up the machine instead of $750. But then the cost per spatula is lower. It's only 20 cents. So we're going to have plus 0.20x. Now, if we solve this equation, that will give us the value of x for which it's the same cost to use the smaller machine or the larger machine. And then we know that if we make more than that, the larger machine ends up being a good deal because all the spatulas we make after that end up being cheaper. We've got variables on both sides of the equation. We've got 0.25x on the left and 0.20x on the right. And whenever we're solving an equation where the variables on both sides, we need to eliminate one of those variable terms so that the variable is only on one side. And we can do that by subtracting 0.20x from both sides. That leaves us with 750 plus 0.05x on the left, because 0.25 minus 0.20 is 0.05. And then on the right, the variable terms cancel, and we're left with 1,200. Now, to get x alone, we need to get rid of that constant term on the left, so we're going to subtract 750 from both sides. When we do that, we're left with 0.05x on the left. And on the right, 1200 minus 750 is 450. And then to get x alone, we divide both sides by 0.05. And that leaves us with x equals 9,000. So we go up to our let statement. We have x equals 9,000. And that was the number of spatulas that they need to produce. And so they ask, how many spatulas must the company produce to make it worthwhile to use the larger machine? And we can say they must produce 9,000 spatulas or more to justify the cost of using the larger machine.